Hey there, future coder, ready to build your very own calculator app? This tutorial will guide you through each step using the power of Python. Don't worry if you've never coded before. We'll start with the basics and explain everything in plain English. By the end, you'll have a working calculator and the confidence to tackle even more coding projects. Let's get started. This tutorial is designed for absolute beginners. We'll break down each concept into small, manageable steps. You'll learn how to write code that performs calculations, then how to create a simple interface for your calculator. Get ready to impress yourself with what you can build. This is going to be fun and empowering. Throughout this journey, we'll be using Python, a beginner-friendly and versatile programming language. You'll gain valuable coding skills that can be applied to countless other projects. So let's jump right in. Ready to start your coding adventure? Let's go. In the next section, we'll set up your coding environment so you can start writing some actual Python code. Before we start writing code, we need to set up a coding environment. Don't worry, it's like setting up a workspace for a new hobby. We'll be using Python, a popular and easy-to-learn programming language. First, you need to install Python on your computer. Head over to the official Python website and download the latest version suitable for your operating system, whether it's Windows, macOS, or Linux. The website provides clear installation instructions. Once installed, you're ready to start coding. Next, you'll need a code editor, a place to write and run your Python code. Think of it as a digital notebook specifically designed for coding. There are many great free options available, such as Visual Studio Code, Atom, or Sublime Text. Choose the one that sounds most appealing to you and install it. Now open your chosen code editor and create a new file. Save this file with a descriptive name like calculator.py. The .py extension tells your computer that this is a Python file. Congratulations, you've just set up your coding environment. You're one step closer to building your calculator. In the next section, we'll dive into writing the code for our first calculator operation. Addition. Get ready to bring your calculator to life. Now the real fun begins. Let's write the code for our calculator's addition function. In Python, we use functions to group lines of code that perform specific tasks. Think of a function like a mini program within your main program. In your calculator.py file, type the following code, python def add xy. This function adds two numbers together. Return x plus y. Let's break down what each line does. This line defines a new function called add. The part means the function takes two inputs, which we'll call x and y. This is a docstring, like a little note explaining what the function does. This line is the heart of the function. It takes the two inputs, x and y, adds them together using the plus operator, and then uses to send the result back. That's it. You've just created your first Python function. In the next section, we'll add another function for subtraction. You're well on your way to building a fully functional calculator. Great job creating the addition function. Now let's add subtraction to our calculator's repertoire. Just like before, we'll define a new function, this time called subtract. Below your existing function, add the following code, python def subtract xy. This function subtracts one number from another. Return x. As you can see, this code follows the same structure as the addition function. We define the function using. We include a docstring explaining what the function does. The core logic is which subtracts the second input, y, from the first input, x, and returns the result. With each function you create, you're adding more power to your calculator. In the next section, we'll tackle multiplication. Keep up the great work. Section 5. Multiplication. Combining numbers with ease. Our calculator is shaping up nicely. Now let's add the ability to multiply numbers. Just like with addition and subtraction, we'll create a new function, this time called multiply. Below your function, add the following Python code, python def multiply xy. This function multiplies two numbers together. Return x asterisk y. You're getting the hang of this. Here's a breakdown. Defines our multiplication function. The docstring explains the function's purpose. Multiplies the inputs x and y using the asterisk operator and returns the result. You've now added the power of multiplication to your calculator. Feel proud of the code you're writing. In the next section, we'll conquer division and complete the set of basic arithmetic operations. Section 6. Division, slicing and dicing numbers. Our calculator is almost complete. Let's add the final basic operation, division. We'll follow the same pattern as before, defining a new function called divide. Below your existing code, add the following function. Python def divide x, y. This function divides one number by another. If y equals sign 0, return division by 0 is not allowed. Else, return x, y. This function has a little extra code to handle a special case. Division by 0 defines our division function. We have a docstring explaining the function. Checks if the second input, y, is 0. Division by 0 is undefined in mathematics, so we need to handle this situation. If y is 0, we return this message to the user. If y is not 0, we proceed with the division. Performs the division using the operator and returns the result. Congratulations. You've now implemented all 4 basic arithmetic operations. In the next section, we'll learn how to create a user interface so you can actually use your calculator. Section 7. Creating the user interface. Our calculator engine is ready. Now let's build a simple user interface, UI, so you can interact with it. For this tutorial, we'll create a text-based UI using Python's built-in function. Below your function definitions, add the following code. Python while true print select operation, print 1, add print 2, subtract, print 3, multiply, print 4, divide, print 5, exit, choice equals sign input, enter choice 1, 2, 3, 4, 5. If choice in 1, 2, 3, 4, try num1 equals sign float input enter first number, num2 equals sign float input enter second number, accept value error print invalid input please enter numbers only, continue if choice equals sign 1, print num1 plus num2 equals sign add num1 num2, elif choice equals sign 2, print num1 num2 equals sign subtract num1 num2, elif choice equals sign 3, print num1 asterisk num2 equals sign multiply num1 num2, elif choice equals sign 4, print num1 num2 equals sign divide num1 num2, elif choice equals sign 5, break print invalid input, please enter a number between 1 and 5. This code might look a bit intimidating, but don't worry, we'll break it down step by step. This creates an infinite loop, meaning the code inside the loop will run repeatedly until we explicitly tell it to stop, etc. These lines print the menu of options for the user to choose from. This line prompts the user to enter their choice and stores it in the variable. This checks if the user's choice is one of the valid operation choices. This block handles potential errors if the user enters something that's not a number. The rest of the code inside the end blocks performs the chosen calculation using the functions you defined earlier and prints the result. If the user chooses 5, the loop breaks, ending the program. If the user enters an invalid choice, an error message is printed. You've now created a fully functional text-based calculator. In the next section, we'll test it out to make sure everything works as expected. Section 8, Testing, 1, 2, 3, making sure it works. It's time to test our calculator and make sure it works as expected. Save your calculator.py file and then run it. You can usually run Python code directly from your code editor. Look for a run button or a similar option. Once you run the code, you should see the calculator interface appear in your terminal or console window. Try performing different calculations using the various operations you've implemented. Test addition. Enter 1 for addition, then enter 2 numbers. The calculator should display their sum. Test subtraction. Choose 2 for subtraction and enter 2 numbers. The calculator should show the difference. Test multiplication. Select 3 and enter 2 numbers to see their product. Test division. Choose 4 and test with different numbers. Make sure to test division by 0. The calculator should display your custom error message. Test exit. Finally, select 5 to exit the calculator. Thoroughly test each operation with different input values to ensure everything works correctly. If you encounter any errors, carefully review your code and try to identify the issue. Debugging is a normal part of the coding process, so don't get discouraged if you encounter any hiccups. Section 9. Congratulations and keep coding. Congratulations on building your very own Python calculator. You've learned how to define functions, handle user input, perform calculations, and create a simple user interface. These are fundamental coding concepts that you can apply to countless other projects. But don't stop here. This is just the beginning of your coding journey. Here are some ideas to further enhance your calculator. Add more operations. Implement more advanced mathematical operations like exponentiation, square roots, or trigonometric functions. Create a graphical user interface, GUI. Instead of a text-based interface, explore using libraries like calcuator or PIQT to create a more visually appealing and user-friendly calculator with buttons and a display window. Error handling. Improve the calculator's error handling to provide more informative messages to the user in case of invalid input or other errors. The possibilities are endless. The more you practice and explore, the more confident you'll become in your coding abilities. Keep experimenting, keep building, and most importantly, keep having fun with code.